Welcome to the Sky Commander Flight Brief. It's your mission-ready podcast for drone pilot training and aerial insights across Canada.
From Transport Canada rules to real-world drone ops, we break it down, take you higher, and help you earn your wings. Because here at skycommander.ca, we don't just fly.
It hints there's more to it. It's a masterclass, a deeper level, maybe a philosophy or a community focus, perhaps.
It's definitely intriguing, sets them apart from just, a basic tips show. Skycommander.ca is the obvious next step. Precisely. If you're thinking about flying a drone in Canada, boom, this content is aimed right at you.
Powered by skycommander.ca.
The elite podcast for Canada's drone pilot. Okay, let's get started. So when you think about, a professional drone operation,
right,
your mind probably jumps to these really complex mapping surveys over, hundreds of acres of land, or maybe some dramatic cinema work for a movie.
For sure, that's the public face of it. That's what people see.
But we've brought this whole stack of sources today, a collection of operational playbooks, some really dense regulatory summaries, and industrial mission reports, and they pull us right into what has to be the most unforgiving airspace of all.
The industrial facility, absolutely.
Yeah, and that's what we're digging into.
That really is the reality. Good. We're deep diving into refineries, chemical processing plants, massive utilities, generating stations.
Wow.
I mean, this is where the entire risk calculation, it just changes fundamentally.
How so?
The margin for error isn't just small, it's zero. Because a single mistake can have these massive safety, environmental, or, economic consequences.
Okay, so our mission for this deep dive is actually really specific. We're building a professional playbook for conquering your very first industrial checkup mission.
Exactly.
And we're treating this not as just a flight, but as a full-blown operation designed to meet four non-negotiable pillars.
And you have to hit all four.
All four. Safety, compliance, data quality, and professionalism.
Yeah.
If you achieve all four, the mission is a success.
And you get invited back. That's the key.
What a goal, right?
And the most fascinating challenge we found in these sources is it's the operational mindset shift required depending on where you operate.
Right.
We are directly comparing the industrial playbook in Canada, which is often defined by its reliance on a mandatory visual observer, or VO.
Okay.
And that's because of its explicit Transport Canada regulatory structure, CARS Part 9. We're putting that against the United States approach.
Just different.
Very different. It often defaults to the highly disciplined solo remote pilot in command, the RPIC, who's operating under Part 107.
So it sounds like what we're really comparing is a highly procedural, almost crew-oriented system versus one that places the full undivided responsibility for visual safety, what you'd call the VLOS burden, onto just one person.
One person.
That inherently changes everything. I mean, from the pre-planning to the actual execution, doesn't it?
It changes the risk allocation, which at the end of the day changes the procedures. You have to adapt your playbook instantly depending on the regulatory spine you are operating under.
Okay, let's unpack this. Industrial sites aren't just big, they're structurally dense, like miniature cities.
That's a great analogy.
And they are just full of these hidden landmines, steam lines, unmapped power lines, active cranes, unexpected thermal plumes.
All of it.
And it's all wrapped in layers of specific, non-negotiable safety regulation.
That mini-city analogy is spot on. And the very first thing any professional operator must internalize is what we call the three bosses rule.
The three bosses.
Yeah.
Okay.
Before your props even consider spinning, you must secure three non-negotiable yeses. If you fail to secure even one,
Just one.
the aircraft stays grounded, and you leave gracefully.
I think the biggest mistake a new industrial pilot probably makes is assuming they only need the client's permission.
Oh, absolutely.
But that only covers one boss, right?
Exactly. The client is important, of course, but they don't override the regulatory structure or, just as importantly, the site's safety culture.
Okay, so let's break it down. Who is boss number one?
Boss number one is the aviation. Yes, this is pure legality. Airspace compliance.
The nuts and bolts of flying legally.
It is. This covers whether you have the necessary air traffic control authorization, so, using LANC or Drone Zone in the U.S., or going through MB Canada up north.
Okay.
And it's whether your flight plan respects the legal altitude limits. But crucially, this boss also demands a clear visual line of sight, or VLOS, plan.
A plan for how you're going to keep your eyes on the drone.
Yes, and in Canada, this is particularly formalized. The regulatory stack specifically CRR 901.27, explicitly requires the pilot to conduct a formal, documented site survey.
A documented survey.
A documented survey to confirm the operational volume is suitable before the operation is even authorized. It's a required step.
So the aviation boss is essentially demanding proof that you've done your homework on the three-dimensional air risk. It's not just the two-dimensional ground risk.
Precisely. They are the gatekeeper for safe access to the sky above that plant.
Okay, so that's boss one. Who's number two?
Boss number two is the HSE-YES, which stands for Health, Safety, and Environment.
Great.
This is, I would argue, the most demanding boss on the ground.
Really? More than the aviation regulator?
On a day-to-day, moment-to-moment basis, yes. They're focused on hazard controls, ensuring you're wearing the mandatory personal protective equipment, or PPE.
So your steel toes, hard hat.
Steel toes, hard hat, fire-resistant clothing, safety glasses, the whole 9 yards. And they need to know that you know where the traffic lanes are, the muster points, the site first aid stations.
So this means the drone operation isn't seen as some magical aerial activity that's separate from everything else.
Not at all.
It's just another high-risk activity like using a scissor lift or entering a confined space.
It is. And the most common manifestation of the HSE boss is the permit to work system.
Ah, the paperwork.
The paperwork. This is a formal written document authorizing specific personnel to carry out specific work at a specific time and location. Your drone flight will be listed as a permit to fly.
But doesn't that introduction of bureaucracy, that permit to work system, doesn't it introduce serious procedural delays?
It can.
Like if the wind suddenly drops or the asset you need to inspect becomes temporarily available, you can't just pivot quickly, right?
That's a legitimate point of friction, and it's one you manage through rigorous pre-planning. The HSE system values predictability far more than it values speed.
Okay, that makes sense.
If you need to change your launch point, you often need a new or an amended permit, which requires a new safety sign-off from the area authority.
So how do you deal with that?
The key is to over-document your intentions in advance. In your initial plan, list 3 potential launch points, not just one. Build flexibility into the permit before you even arrive on site.
So you're sacrificing that on-the-spot responsiveness.
You are.
For auditable safety.
Auditable safety. That's the perfect way to put it.
That's a crucial insight. Safety isn't just about mitigating physical risks. It's about navigating the administrative safety structures of the plan.
100%.
So we have the aviation boss and the HSE boss. Who is the final boss?
Boss number 3 is the security EC. This covers physical access.
Mm-hmm.
Do you have the necessary badges or escorts?
Just getting in the gate.
Just getting in the gate.
Yeah.
But it's also, can you fly near or over restricted areas? Things like server farms or sensitive storage areas. And most critically, they govern data handling. They need to know exactly what you're capturing. Are you accidentally filming proprietary equipment? Security weak point.
Yeah.
And then how that imagery will be stored, transferred, and potentially destroyed later.
So they're protecting the plant's intellectual property and its physical assets?
Yes. They're the guardians of the plant's secrets, in a way.
So to recap, the aviation boss handles the sky, the HSE boss handles the safety of the workers, and the security boss handles the plant's critical assets and data vulnerability.
That's it.
And missing a single yes here means immediate stand down, getting removed from site.
And likely being permanently blacklisted.
Yeah.
Absolutely. The industrial world is small, your reputation precedes you.
Wow. That sets a profoundly high bar for pre-planning, which leads us right into phase 1. Locking the scope.
It does.
The sources stress this necessity of creating a mission definition one-pager, something you do 48 to 72 hours before arrival.
Yes.
And this is designed specifically to fight the dreaded scope creep.
Scope creep is the silent killer of professionalism. It really is.
What does that look like in this context?
Well, you arrive planning to inspect Roof A, and suddenly, because you're carrying a camera, the client asks you to visually inspect a live steam relief valve in a pipe rack canyon 2 miles away because they just saw a puff of white smoke.
And you're not prepared for that.
Not at all. Different hazards, different flight plan, no permit. It's a recipe for disaster.
So the power of this one-pager is that it forces the customer to align their expectations with reality before the operation even starts.
Exactly.
What are the required contents for that document? What absolutely has to be in there?
It starts with a clear, singular objective. For example, conduct an aerial condition check of asset groups 1, 2, and 4. Super specific.
Okay.
Then you list the specific assets you will cover. The cooling towers, the main administration building roofs, and the primary flare stack. It forces both parties out of these vague generalizations.
And defining the deliverables, Annotated photos, thermal stills, maybe a short overview video. That ensures you bring the right equipment and workflow.
It does.
But the real magic here, I think, is in defining done, defining it in concrete, measurable terms.
That specificity is the key to customer satisfaction. It prevents ambiguity. You can't just promise a roof inspection.
Right. What does that even mean?
Exactly. You have to specify the coverage rule, something like inspection of all administrative and pump house roofs will include captured evidence of corners, edges, all known penetrations like vents or HVAC units, and all drain points.
That level of detail transfers the assessment from a subjective opinion to an objective, measurable delivery.
It gives you a clear checklist that you can audit yourself against as you fly. But equally important is using that same one-pager to list your critical exclusions.
Okay.
This is your primary shield against unsafe on-the-spot requests.
So what are the typical exclusions you have to explicitly list out?
Active flare stacks, you need special permission and very specific procedures to fly near those. So default is no.
Makes sense.
Any flight over known active construction or maintenance crews. That's a hard no. A hard no-fly zone around any active crane, especially if you haven't received confirmation that the crane is locked down and secured.
That's a huge one.
Huge. And of course, no filming of security-sensitive infrastructure, even if you can see it from the air, unless it was pre-approved by security boss number 3.
That's a really powerful move because if the client asks for something outside that scope on the day of the flight, you just point back to the agreed-upon document, and it makes delivering that professional no so much easier.
It turns "I can't do that" into "as we agreed in our mission definition, we define this area as an exclusion for the safety of your team." It shifts the responsibility of that decision to the pre-agreed safety policy.
Brilliant.
And finally, there's this small but really high-value step the sources call the customer love move.
Okay, I'm intrigued. What's that? Sending the one-pager to the client representative the day before arrival?
That's it. It seems minor, but it demonstrates meticulous professionalism. It forces one final point of alignment, and when you show up, the client already knows your plan. They know you respect their environment.
So it transforms you from just another vendor
and to a professional partner.
We've established that compliance is the bedrock. It's not just about avoiding fines. It's about providing an auditable safety foundation for operations in these high-risk zones.
Absolutely.
But the requirements differ so radically across the border, forcing pilots into these fundamentally different planning mindsets.
That's where the deep dive into the regulatory spine really starts. Let's begin with the Canada Essentials, the whole CARS Part 9X mindset. This is a system built on established procedures and really explicit documentation.
So what really defines the Canadian approach? What's the core of it?
The first non-negotiable legal requirement under Canacol 901.27 is the site survey. I mentioned it before, but it's that important.
It's explicitly required.
It is explicitly required for any complex operation. The pilot must conduct a formal analysis to determine the operational volume is suitable. This isn't just, eyeballing the site from Google Maps.
Right.
It means systematically considering the airspace classification, checking current NOTAMs notices to air missions, analyzing potential approach routes for full-scale aircraft, even if they're rare.
Even if it's unlikely.
And documenting all the identified hazards before the operation begins.
So the pilot isn't just documenting their flight path, they're essentially acting as a miniature air traffic analyst for that specific operational volume.
Precisely. They have to think, is this slice of air viable? Is the terrain suitable for an emergency landing? Are there obstacles like new power lines that aren't visible from satellite imagery? This mandate forces a level of pre-planning rigor that really sets the Canadian framework apart from the default U.S. solo op.
And related to that rigorous planning, the CARs also mandate that established procedures must exist.
That's right. Both normal procedures, things like your pre-flight checklists, your communication protocols, and emergency procedures must be established, available, and reviewed by the entire crew.
So you need a written plan.
You must have detailed, written plans for handling a command and control link loss, for equipment failure, a sudden control station failure, or a flyaway scenario.
And you have to have that with you.
If Transport Canada audits your operation, they expect to see those written procedures, and they expect proof that you reviewed them at your tailboard brief that morning.
That really pushes you into a true crew mentality, even if it's just two people, the pilot and the observer.
It absolutely does. And given that so many large Canadian industrial sites are near controlled airspace, Controlled airspace under CAR 901.71 requires explicit authorization from the air traffic services provider, which is typically NA Canada.
And you have to have that authorization handy.
You must have that authorization accessible to the crew during the operation, confirming your time slot, your altitude limitations, everything.
And finally, the prevalence of the visual observer, the VO, in the Canadian context is highly relevant here.
It is. If a VO is used, the regulations explicitly expect reliable and timely communication. The VO is integrated as an essential safety layer. They're helping manage the complexity and the sightlines of these massive industrial plants, often extending the effective visual line of sight that the pilot can safely use.
Okay, so that's the Canadian side. Very procedural, very documented.
Very.
Now, let's pivot and look at the USA Essentials under Part 107. Given the critique that the U.S. model often defaults to a solo mindset, how does that regulatory burden shift away from procedural rigor and onto the individual pilot?
The shift is huge. It's a fundamental change in philosophy. The core difference is the VLOS burden under 14 CFR 107.31.
The visual line of sight burden.
In the U.S. solo context, the RPIC, the remote pilot in command, is solely responsible for maintaining visual line of sight. They alone must know the drone's position, its attitude, its direction of flight, and they must ensure it can avoid all hazards, people, other aircraft, structures, all of it.
So the U.S. system relies heavily on the constant, proactive vigilance of one single person.
Yes.
Whereas the Canadian system builds in a mandated procedural safety net with the crew.
Precisely. And this forces the U.S. solo pilot to fly fundamentally differently on an industrial site.
How so?
If you fly behind a pipe rack or a large tank, you have broken VLOS, period. You are non-compliant, unsafe, and illegal.
So what does that mean in practice?
It forces the solo pilot to accept flying much shorter, tighter segments and constantly moving their launch location, sometimes every 5 or 10 minutes, just to keep their eyes on the aircraft.
That must inherently slow down the mission and require an immense amount of physical effort from the pilot. I mean, you're walking around this huge plant all day.
It absolutely slows down the data collection, but it increases the safety compliance. You are trading collection speed for legal VLOS assurance.
And what about airspace?
Regarding airspace, prior ATC authorization is mandatory in controlled airspace. That's part of 107.41. And the LANC system, or drone zone, has made that fairly efficient. But the paperwork must be done and it must be accessible on site.
And we can't overlook the elephant in the U.S. airspace now, remote ID.
No, compliance is no longer discretionary. The FAA ended that grace period. Professional industrial operators must ensure their aircraft are compliant, broadcasting their location, and operating legally.
And the clients will demand that.
Clients in regulated industries will not tolerate the regulatory risk of a non-compliant aircraft operating on their premises. It's a non-starter.
And just briefly touching on operations over people, that's a strict no-fly zone in a dynamic industrial environment, unless you've met the very, very specific conditions laid out in Part 107.
On your first industrial mission, the best practice is simple. Just assume you cannot fly over any person, any vehicle, or any occupied structure. It removes an entire layer of complexity and risk assessment that is just unnecessary for a standard asset inspection.
Okay, now let's drill down on what might be the most critical operational difference for this kind of work. Altitude limits the structure exception.
Yes.
For pilots working near these really tall assets, flare stacks, silos, distillation towers, mixing these rules up is a career-ending mistake.
This is where the geometry is entirely different and you have to get it right. Let's start with the USA rule.
Okay.
The standard limit is 400 feet above ground level, AGL. But the exception, which is critical for industrial sites, allows you to fly within a 400-foot radius of a structure.
So horizontally.
Horizontally.
Yeah.
And not higher than 400 feet above that structure's uppermost limit.
Okay, let's visualize that. If I have a 500-foot tall stack, my drone can legally fly up to 900 feet AGL.
Correct.
Provided I stay within 400 feet horizontally of that structure, that's a massive margin.
It is. It gives you both the vertical access you need to inspect the highest point and a horizontal buffer zone that allows for safe flight around the top of the tower. It recognizes that inspecting these things requires flying well above 400 feet AGL.
Now, how does the Canadian rule handle that exact same scenario?
The Canadian rule is much tighter. It has different geometric structure entirely. The standard is also a max 400 feet AGL, which is about 122 meters. But the structure exception only allows you to go up to 100 feet or 30 meters above a building or a structure.
Only 100 feet.
And you must remain within 200 feet or 61 meters horizontally of that structure.
So using the same 500-foot stack example in Canada, the absolute maximum altitude you could legally fly while inspecting the top would be 600 feet AGO.
600.
And you have to stay within 200 feet of the structure horizontally.
Exactly. The Canadian rule provides way less vertical and horizontal margin compared to the U.S. rule.
And that's a huge gotcha.
It's a huge gotcha. If you are a U.S. pilot attempting to apply that generous 400-400 rule in Canada, or a Canadian pilot assuming you only need 100 feet of margin in the U.S., you are violating airspace rules, and you're increasing your operational risk profile significantly. Mastering this geometric difference is paramount for any cross-border industrial work.
Okay, we've nailed the regulatory spine, we've locked the scope. Now, the real test. Translating that mountain of paper into safe, actionable steps on the ground.
Right.
Here's where it gets really interesting. Once we're checked in, what is the mindset shift required to manage the physical complexity of the plant?
The mindset has to be about running the job site, like an airport.
I like that.
You cannot treat this like a casual hobby flight. It requires the safety discipline of an industrial site, meaning you follow every PPE rule, you respect every sign, combined with the procedural rigor of an aviation operation.
So what does that look like on arrival?
Arrive early. Sign in. Get the mandatory site safety orientation. Walk down your launch points, especially looking for new hazards that weren't on the map or on the satellite images. Integration is mandatory. You are part of their system for the day.
And the practical culmination of all that planning is the tailboard briefing. This isn't just a friendly chat, is it?
No, this is the mandatory auditable proof of your established procedures.
Okay.
It's especially vital in the Canadian context, but it's best practice everywhere.
And it has to happen every time.
It must happen, even if it's just you, the pilot, and the site safety representative. The purpose is to ensure every single person involved understands the plan and, more importantly, the emergency response.
Okay, so what are the key elements that need to be explicitly scripted out in that briefing?
You start by defining the mission and the boundaries, reconfirm the assets you're inspecting and the exact 3D operational volume you'll be using.
Got it.
Second, you clarify the roles. Who is the pilot, who is the VO, and who is the site rep, and what is that site rep responsible for? For example, maintaining the cordon, managing unexpected traffic.
And communications, especially in a loud environment where, ear protection is often mandated.
Crucial. You define your primary and backup communications. What radio channel are you on? What are the backup hand signals? And you establish the specific, standardized, non-negotiable stop phrase.
Okay.
Must be the same every single time. Stop FLY, stop FFI, stop FY.
Yeah.
This phrase means immediate non-negotiable mission termination and a controlled landing.
And you have to rehearse it.
You have to rehearse it, say it out loud. It removes ambiguity and panic from the most critical safety moment.
I really like that idea of the rehearsed stop phrase.
It provides psychological safety. Everyone knows what command overrides all others. And finally, the emergency planning. Explicitly confirm the drone's lost link behavior.
RTH, hover, land.
RTH altitude, hover, or immediate land. You define your two pre-selected emergency landing zones, or ELZs, and you verify the location of the site muster point in case an evacuation is required.
That briefing transforms the site rep from just a passive observer into an active safety component of your operation.
Yes, and it creates the auditable trail that proves you followed your established procedures, which is critical for insurance and any regulatory review.
Okay, next we move from the safety briefing to defining the physical space. Building the operational volume. The invisible 3D box.
Right.
This is where you overlay that regulatory compliance box onto the plant's real-world hazards.
And this requires moving beyond simple maps and using the StackSS mnemonic to ensure you haven't missed any industrial-specific hazard that will kill a drone or, worse, cause a near miss.
StackSS. Okay, let's break down the StackSS analysis for the listener, focusing on the specific industrial hazard of each letter. What's S?
S is for structures, and not just the assets you're inspecting, but the structures that pose a risk to you.
Right.
Mobile cranes, heavy machinery, and especially unmapped utility lines, high voltage lines that might be obscured by other things.
And these can be dynamic.
They are. The hazard here is dynamic. You have to establish a hard no-slide bubble around any crane, whether it's active or inactive. A crane moving unexpectedly can instantly terminate your flight and your career.
Okay, S is structures. T.
T is for traffic. And we aren't talking about car traffic on a highway. We're talking about sudden, heavy, unpredictable movements.
Right.
Forklifts, haul road, shift change paths. These are unpredictable vectors for people or vehicles suddenly entering your operational zone.
So what's the mitigation for that?
Communication. You communicate with the site rep to ensure temporary cordons are established during your flight window, or you simply pause operations entirely during a shift change.
Okay, ST, what's A?
A is for aircraft. Many of these facilities have private helipads or are situated under low-flying medevac routes.
So you have to be ready for that.
If you hear any inbound call from site operations, a helicopter, even a small fixed-wing aircraft, it is an immediate land command. Not RTH, but a manual controlled land in your predefined emergency landing zone. Full-scale aviation always has priority.
No question. Okay, STA.
C is for comms. This is where the physical environment actively fights your technology.
How so?
Plants are electrically noisy steel forests. They cause RF interference and lost link zones. The sheer density of metal tanks, pipe racks, conduit, it reflects and degrades your control link and your video feed.
So you can just lose connection.
You have to map the areas where you know signal strength will drop, and that forces you to reposition your launch point or choose a lower risk flight path to avoid those dead zones.
Okay, Stakeholder.
K is for kinetics. This is the invisible enemy. Thermal plumes and wind shear.
This is the risk factor I think new pilots fail to calculate.
Almost always. The hot exhaust from stacks or large processing units creates powerful thermal turbulence and updrafts. Your drone, which relies on calm air, can be pushed up or down unexpectedly.
And that can lead to instability or loss of control?
It can. You have to fly slower and with a much wider buffer zone around these heat sources.
And the final S in stacks.
And the final S is for security. Beyond the access issues we talked about, this refers to sensitive assets. You must agree on your camera angles in advance to ensure you aren't capturing proprietary information, internal schematics, or specific security weak points that the client does not want leaving the premises.
So if you map stacks,
you've mapped the environmental, kinematic, and security risks of that mini-city.
Let's dive deeper into those two invisible risks, starting with GNSS multipath. Why exactly does the drone's GPS struggle so much near that steel forest?
Okay, so a global navigation satellite system, or GNSS, which includes GPS, relies on receiving clean, direct signals from multiple satellites to triangulate its position in space.
Right.
When you are flying near dense, reflective metal structures, think huge storage tanks or these canyons of pipe racks, those satellite signals bounce. The drone's receiver doesn't just get the direct signal, it gets these delayed, reflected copies of the signal.
So the drone thinks it's stable, but the location information it's getting is actually unreliable.
Exactly. This is called multipath. If the drone is relying heavily on GPS for its position hold, that position hold will start to drift unpredictably.
What does that look like from the pilot's perspective?
You might see the drone slowly walk toward a pipe rack even though your stick input is completely neutral. It can also cause temporary, localized compass weirdness because of all the high electromagnetic activity leading to unpredictable yaw or rotation.
So what's the concrete mitigation for this? How do you fly in that environment?
First and foremost, you increase your standoff distance. You just fly further away. Second, you avoid automated close quarters paths on your first mission. Don't rely on the computer.
Fly it yourself.
Fly it yourself. And most critically, monitor your GNSS health display constantly. If the number of connected satellites drops significantly, or if the horizontal dilution of precision, the HDOP spikes, you immediately switch to an attitude mode, or just be prepared to fly fully manual with confident visual guidance.
So you have to trust your eyes over the GPS reading in those steel forests.
You must.
And the other invisible killer, thermal turbulence? How high can a thermal plume from a stack actually push a small drone?
Oh, these plumes can rise hundreds and hundreds of feet depending on the heat output and the ambient wind conditions. For a small commercial drone, that column of hot rising air can act like an unexpected elevator.
Pushing you up rapidly.
Pushing you up rapidly. And conversely, the cooler descending air around the plume's edges can cause a sudden sink. The drone is constantly fighting these rapidly changing air densities and shear forces.
And if that happens mid-inspection, it can ruin your data quality or worse, push you too close to the stack structure itself.
Yes. Mitigation involves flying with increased standoff, give that stack a wide berth, fly slower so the autopilot has more time to compensate for any sudden changes, and always plan clear downward escape routes, not sideways ones, in case you get caught in a strong updraft.
So the planning is intense and the hazards are mapped. Let's shift to the flight execution itself. To translate this planning into a safe mission, the sources recommend this repeatable, safe structure known as the 4-block method.
This method ensures you systematically test the air and the systems before you commit to any complex, close-quarters data collection. It builds confidence iteratively.
Okay, so block 0 is ground validation. This must be religious. What are the key checks here?
First, confirm the home point is locked and accurate. Obvious, but critical. Then verify the RTH altitude.
And that has to be safe and legal.
Safe and legal. It must be high enough to clear the highest known obstacles, cranes, cable trays, pipe racks, but low enough to remain compliant with your airspace authorization. Check your battery policy. And lock the camera settings.
Why is locking the camera settings, exposure, white balance, ISO so critical on an industrial site?
Because of the dynamic lighting. You're often flying from the extremely bright sunlit top of a storage tank into the heavily shaded area beneath a pipe rack or into the glare from reflective metal structures.
Right.
If your camera is set to auto exposure, it will hunt violently, trying to balance the light, and will ruin the contrast and sharpness of your evidence shots. Locking the settings ensures you get consistent, usable evidence regardless of the shadows.
Okay, that makes sense. So block 1 is the warm-up hover perimeter pass. This is your system check in the air.
It's low risk, low altitude, short duration. Its purpose is purely to confirm stability and comms response. If the GPS is jittery or the drone seems to yaw slightly without any input, this is your time to spot it.
And there's a golden rule here.
The golden rule is, plants punish denial. If the system feels off, if you have an ambiguous warning on your screen, land immediately. Check the logs, reset the system. Don't push through a sketchy feeling.
That's great advice. Okay, so block 2 is the baseline overview. This is about client context.
It is a smooth, high-level, wide pass that gives the client the map in their head. It helps orient them to the overall layout and the relationship between the assets you're about to inspect. This is the visual anchor that makes all the detail shots meaningful later.
And finally, block 3 is the asset-by-asset inspection, the real work.
This is the core data collection. You use your predefined mission definition, and you tackle assets systematically, roofs first, then tanks, then stacks. You keep each flight short, focused, and you ensure you capture the wide, medium, tight, or WMT evidence pattern for each point of interest.
The structure of that flight operation brings us right back to that crucial contrast we started with.
Yes.
The VO-enabled approach, typical of Canada versus the USA solo strategy. The integration of a VO changes the entire operational geometry and the risk mitigation strategy.
It absolutely does.
The VO isn't optional fluff in Canada. They are a necessary risk control system. If you are operating under the Canadian model, what is the VO's job description? And maybe more importantly, what are they not supposed to be doing?
The VO's job is explicitly safety, VLOS assurance, and hazard callouts. That's it. They are looking 360 degrees, scanning the sky for other aircraft, watching for people entering the zone, and ensuring the pilot always maintains visual contact with the drone, especially during complex maneuvers near structures.
And what are they not doing?
They're not supposed to be flying, operating the camera, or staring over the pilot's shoulder at the screen. That's a distraction from their primary safety role.
So, if the VO is that focused on safety, standardized communication is key. The sources emphasize a specific VO phrasebook.
Vague language slows down response time in an emergency. The communication must be fast and decisive.
So give me an example.
If a person breaches the cordon, the VO must use the agreed-upon stop phrase. Stop flyby, stop flyby, stop flyby, person entering zone. If they're losing visual confidence because the drone is far away, VLOS, weak, recommend reposition. This standardized phraseology is trained, and it minimizes the time it takes the pilot to act.
And strategically, where should the VO be placed relative to the pilot? It's not just side by side, is it?
Counterintuitively, the VO should rarely be placed directly beside the pilot. The best placement is where the VO can see what the pilot cannot.
They're blind spots.
They're blind spots. So behind the pilot, managing the ground risk, and critically, at a slightly elevated or different vantage point where they can sweep the airspace above and around the immediate flight path. They're looking for unanticipated aircraft or obstructions like crane booms. They are providing safety coverage for the pilot's perception bubble.
That makes perfect sense. They are extending the pilot's senses. Now, let's consider the USA solo strategy. If the pilot is carrying that full VLOS burden alone, how does that change the operational reality?
The solo pilot has to internalize a fundamental truth. Their effective operational volume is significantly smaller and shallower. You must shrink the operational volume.
Okay.
The solo pilot cannot rely on someone else to manage the environment while they're looking at the screen. You have to embrace the mantra. Small box, perfect coverage, beats big box, risky coverage.
So if the pilot can't see the drone, the flight stops. That means repositioning isn't just a suggestion, it's a mandatory safety procedure.
It is the defining characteristic of the solo industrial mission. You have to plan multiple adjacent launch points. The flight segments are shorter, often lasting only until the drone is about to fly behind the first layer of steel, a tank, a pipe rack, a boiler.
And then what?
Then you land, you move your controller, you move your feet, and you relaunch from the next vantage point to maintain that VLOS reliability. You have to accept that you will spend more time walking and setting up than you will flying.
And given that the pilot is the only one managing the entire environment, they need greater physical margins?
Increased margins across the board. That means increasing your standoff distance from hazards like cable trays, exhaust vents, and pipe racks. And critically, increasing your battery reserve.
So you land with more juice left in the tank.
And that extra capacity is not for flying longer. It's for conservative, controlled recoveries when you have to land or reposition unexpectedly. If you normally fly until 30% battery, you fly until 50% on a solo industrial job.
The reality for the solo pilot is a highly disciplined, constantly moving dance designed around the absolute necessity of maintaining VLOS.
It forces maximum conservatism in your flight paths.
And that discipline must be enforced by a clear set of stop-fly triggers, regardless of whether you have a VO or not.
Absolutely.
We mentioned a few, but what are the non-negotiables that demand an immediate controlled landing?
The immediate triggers are: 1, any person entering the operational zone who cannot be instantly cleared out. 2, any unexpected aircraft or helicopter activity near the plant. 3, if the wind or turbulence near a stack suddenly exceeds your comfort or the drone's safe operating limits. And 4, persistent, unresolvable GNSS or compass warnings.
And you have to have the discipline to follow those triggers.
You must have the discipline to land and reset the mission rather than push the safety boundary just to get the shot.
We've spent the majority of our time talking about getting the drone up safely and compliantly. But as we established earlier, the client isn't buying flight time.
Not at all.
They are buying decision-grade evidence. They're paying to reduce uncertainty and to streamline their maintenance planning. So this final segment has to shift from flying to value delivery.
That shift in focus is the key to repeat business. High-value data comes from structured capture discipline, not just from good flying. And the sources are very clear on the necessity of using the WMT wide-medium type pattern.
Okay, explain how that structure ensures we deliver maintenance-ready evidence. What does that mean?
The WMT pattern provides the necessary context for the maintenance crew or the engineer who's going to review the evidence later. Wide is the contextual shot. It captures the full asset, the stack, the tank, the entire section of pipe rack, and it shows its location relative to the rest of the plant.
So it answers the question, where is this thing located on the map?
Exactly.
Okay, so medium is about zooming into the area of interest.
Yes, it captures the component set. If you're looking at a pipe rack, the medium shot shows the group of valves, the joints, or the area of penetration where a leak might occur. It localizes the area of concern on the asset.
And tight is the definitive proof.
Tight is the defect itself, the rust, the crack, the label, the hotspot, the evidence of damage. But here's the key rule. If you find a defect, you need 3 specific evidence shots to make it actionable for the client.
3 shots for every 1 defect. Why 3?
First, a clean ID shot that captures the asset tag or the unit number. The engineer needs to know which stack or which valve this is.
Okay.
Second, a context shot, that's your medium shot, that shows the defect's location relative to the whole asset. Is the crack near the base? Is it near the top flange? And third, a clear, tight shot of the defect itself.
So if you deliver those 3,
the client can immediately create a work order without a follow-up visit.
That shifts the paradigm from, I took a cool photo of a crack, to here is the auditable, locatable evidence required for your workflow.
Exactly. You are integrating into their industrial process, not just giving them pictures.
The success of the mission isn't confirmed until after you land. The post-flight win hinges on one crucial immediate step: the quick look.
The quick look is critical. Before you pack up, before you leave the site, you must show the client rep a small, curated set of 10 to 15 images or a few video clips on a tablet.
And this serves 2 purposes.
2 purposes. First, it proves coverage. Yes, we hit all the corners of roof 1 as we agreed. Second, it manages expectations and it prevents a follow-up trip. If the client sees the evidence and realizes they missed asking you to look at a vent pipe,
they can tell you, while you were still there.
While you're still on site.
That saves massive time and money. And immediately following that, the on-site debrief needs to be short and high value, maybe 5 minutes max.
Keep it factual and concise. Clarify what was captured successfully, but equally important, clearly state what you could not safely capture and why.
For example,
So our Stack 4 was active, so we deferred that inspection based on our exclusion list. And if you're comfortable, offer 3 neutral observations they should follow up on. Don't provide engineering analysis, just say, we observed significant discoloration on the north side of tank 2.
Now for the moment of truth that determines rehire. Frictionless data delivery. What kills repeat business faster than anything else?
Leaving the site without verifying files are saved, intact, and readable. That's a cardinal sin. If you promise data and you deliver a corrupted SD card, you won't be back.
And after that?
After that, it's delivering a chaotic, unorganized data dump. Clients dealing with maintenance, legal, or engineering teams hate having to reorganize your raw data. They just don't have time for it.
So we need a clean structure for the delivery. The sources provide a great folder template for this.
Use a consistent, simple structure. For example, 01 overview, 02 roofs, 03 pipe racks, 04 tanks, and then a dedicated 06 findings annotated folder.
And the numbers help.
The numerical prefix ensures chronological or logical sorting, and the clear names allow anyone to immediately find the data they need. Consistent file naming is also key. Use asset tags or location identifiers right in the file name itself.
And to really elevate the delivery and justify the expense, what are some high-value deliverables that go beyond just the raw files?
Adding a short findings table is excellent. This is a neutral spreadsheet listing observations, missing insulation on joint, evidence of standing water, correlated directly to the image file name and the asset tag.
So it's an index for the problems.
It acts as an immediate work order starter. Also, include a coverage map screenshot, a markup site plan showing exactly where you flew, your completed zones, and where you had to defer. This shows professionalism, completeness, and predictability.
So, to summarize the entire operation, what is the core professional mindset that guarantees rehire in this unforgiving industrial world?
It's defined by conservatism and predictability. Do be conservative with your margins, be absolutely predictable in your procedures, keep the entire operation boring, because boring equals safe and auditable, and diligently document every anomaly or risk mitigation action.
And the don't.
Don't ever break VLOS, don't fly just a bit closer because the client is pushing you, and never ever fly casually over workers or traffic. You are an aviation professional on critical infrastructure. Act like one.
That really ties the entire deep dive together. The difference between the Canadian requirements for explicit documented procedures, mandatory site surveys, and crew integration via the VO.
Right.
And the USA's reliance on the strict solo VLOS burden, it all distills down to one thing: an operational discipline that prioritizes safety over speed.
That discipline is your ultimate tool. Whether you're manually flying shorter segments and moving your feet every few minutes as a solo USRPIC, or you're executing a detailed 6-point tailboard briefing in Canada, the goal remains the same.
Which is?
To reduce the inherent risk profile of the entire job site while you are operating there.
So what does this all mean for you, the listener, who's looking to move into this space?
I think the most powerful phrase you can use with a client is this: I'm here to reduce your uncertainty and make your maintenance decisions easier safely and without disrupting your operations.
And that clarifies your role.
It immediately clarifies that you are a solutions provider, not just a drone pilot.
And here is a provocative thought for you to carry forward as you develop your own professional playbook. We know the regulatory landscape is constantly expanding. The U.S. has tightened remote ID enforcement, making compliance absolutely non-negotiable.
It is.
While Canada is planning major regulatory changes starting in November 2025 that will enable concepts like BVLOS beyond visual line of sight and EVLOS extended visual line of sight in a more standardized way.
A huge change is coming.
It is, and this raises a really important question for all industrial operators. In a high-risk setting, if the rules governing the drone technology are constantly expanding and shifting to allow more complex flights, how much of your long-term success relies on mastering the current compliance stack versus developing a fundamental, unchanging mastery of industrial safety, predictable communication, and crew discipline that transcends the specific technology you happen to be flying that day? That's a wrap on today's mission, Commander. See above, go beyond, get ahead. For more training, tools, and intel, head to skycommander.ca. If you learned something new, share it, subscribe, and leave us a 5-star debrief.